Today's lesson is on the product property of logarithms. So we've been dealing with logarithms, and there are three different properties, but we're only focusing on the first one, which is the product property. All right, so the official property, product property. Before I give it to you, I want you to go back and think about when we were dealing with properties of exponents. So like a to the power of m times a to the power of n was a to the power of m plus n. And remember, logarithms, they're kind of similar to exponents, inverses of each other. So if you have log of base b of a product, m times n, that is the same as log base b of m plus log base b of n. So we can break the product up into addition. Okay, so we're going to look at expanding and condensing logarithms using that property. So if I have log base 2 of 7 times b, how do you expand it? In other words, break it up into its addition. So log base 2 of 7 plus log base 2b. So it means the same thing. I've expanded it. All right, so condense just means go backwards. So if I have the addition log base 5 of 2 plus log base 5 of 6, it equals, now I forgot to say this part, but it is important that the bases are the same. This property only works when the bases are the same. Okay, so when I have the sum of two logarithms of the same base, you can condense it into log base 5 of, what is 2 times 6? It is 12. Okay, we are going to look into solving logarithmic equations using that property. And I'm calling this part A. I just kind of broke it up into part A and part B. Part A is when we have an equation where the log is just on one side. All right, so here's an example. There's, a lot of variations with solving these, and I'll start with like an easy one and then a more difficult one. So log base 3 of 3 plus log base 3x equals 4. We're solving. We're trying to find the value of x. Well, my property here says, I have the sum of logarithms. I can condense it into log base 3 of 3 times x. So condense it into one logarithm, and that equals 4. Now to finish solving, convert your logarithm into exponential form. So its exponential form is base b to the power of 4 equals 3x. Base 3 to the power of 4 equals 3x. And now just solve for x. Well, 3 to the 4th power is 81. 81 equals 3x. Divide by 3, divide by 3. So x equals 27. All right, now let's look at one that's a little more complicated. So I've got log base 9 of x minus 5 plus log base 9 of x plus 3 equals 1. So same base, two logarithms separated by addition. First thing, let's condense. So log base 9 of the binomial x minus 5 times x plus 3 equals 1. All right, so what comes to your brain when you see this? You should think FOIL. So I'm just off to the side writing x minus 5 times x plus 3. If I'm going to multiply those, I've got my first x squared, outside 3x, inside negative 5x, last negative 15. And then combine like terms, x squared minus 2x minus 15. All right, so let's write this as log base 9 of this full thing, x squared minus 2x minus 15 equals 1. All right, so now that it's condensed, change your logarithm into its exponential form. So that's 9 to the power of 1 equals x squared minus 2x minus 15. All right, how do we solve this? Anytime we have an exponent, let's look to solve by factoring. To solve by factoring, we have to have our equation set equal to 0. So 9 to the first power is just 9. I'm going to subtract 9 and subtract 9. So 0 equals x squared minus 2x. Negative 15 minus 9 is negative 24. Now I need to factor this. So 0 equals, I'm going to factor it. I don't have a leading coefficient here, so x and x. All right, what are factors of negative 24 that add up to negative 2? That's going to be negative 6 and positive 4. X minus 6 and x plus 4. To solve by factoring, this is when you have to break it up into two different equations. So x minus 6 equals 0, or x plus 4 equals 0. So x equals 6, boom. X equals negative 4, boom. Now, in logarithms, when we're solving for x, we have to check for extraneous solutions. And the reason is a logarithm, let's just say log base 5, let's say I write negative 2 equals a number. So let's think about that. Can 5 to the power of x equal a negative number? If the base of an exponent is positive, we can never have a negative. So in most cases, you can go ahead and cross off your negative, but you actually do need to double check, because it's, if we plug in here for x, at the very beginning, will the result of this be negative? So my values were x equals 6, so 6 minus 5 works. And then 6 plus 3 over here, that'll work. It works in both. Negative 4. Negative 4 minus 5. So x equals negative 4 when you plug it in. Well, that's not going to work. So in this case, that negative is a fake out solution, extraneous. So 6 is the only solution that works. All right, now we're solving logarithms using this property part B. Part B, I am calling, is when you have an equation with a log on both sides. Okay, so here's an example. Log base 2 of 6 plus log base 2 of x equals log base 2 of 48. All right, so it looks more complicated, but actually it's not too bad at all. So let's think about this. Anytime we have the addition, we need to condense it. So log base 2 of 6 times x is 6x equals log base 2 of 48. All right, well, I have two log base 2s and they're equal to each other. The only way that they're equal to each other is if this equals this. So I don't even need to worry about exponential form. I just need to know that my 6x has to equal 48 for this to be equal. Oh, 48. So then solve for x. Divide by 6, divide by 6, x equals 8. And we're done. All right, here is our last example of the lesson, part B again. And we're going to deal with the factoring again. So let's check it out. I've got log no base, which means base 10, plus log of x minus 1 equals log 42. All right, solve for x. Two logarithms separated by addition, condense them. So it's log of x times x minus 1 equals log of 42. All right, well, if we have log on both sides, the same base, and they're equal to each other, then that means this part has to be equal to this part. So I don't even need my logarithms anymore. I just know that x times x minus 1 equals 42. To solve for x, I need to distribute. X times x is x squared. X times that minus 1 minus x equals 42. Anytime you have something squared, let's try to solve by factoring. It needs to be equal to 0, so x squared minus x. I'm going to bring the 42 over, so it's minus 42. All right, so let's see, I need to factor this. So I don't have a leading coefficient here other than 1. So I can go straight into x and x. What are factors of negative 42 that add up to negative 1? And it's going to be minus 7 plus 6. Break them apart. X minus 7 has to equal 0. X plus 6 has to equal 0. So x equals 7. X equals negative 6. Check for extraneous solutions. So 7 and negative 6. Let's go back up to the top. 7 and negative 6. Well, let me get a different color. 7 and negative 6. Right here, 7 works, but 6 is not going to work because we cannot have logarithm of a negative number. So 6 will not work, but let's check 7 over here. 7 minus 1. Okay, that still works. So, fake out solution, real solution. There's your full lesson on solving logarithms using the product property. Good luck.